Let's take a look at this example. Please notice that we have given two currents, I2 and I3. If you are going to use KCL, you are going to find the current I1, which is at the same time I total, okay? So you can say that I total is equal to I1. Why? Because I total goes through resistor R1 directly, okay? So I can write that I total is equal I1, and this is nothing else, just the sum of two currents, I2 and I3. Why? Because I total is going to split, right, into two currents, I2 and I3. So I have I2 plus I3, where I2 is equal 3 milliamps plus I3, which is equal 12 milliamps. Everything is equal 15 milliamps. Okay, so I found I1 and I found also I total. Next, I have I total and I have voltage source. Okay, if you are going to use Ohm's law, you can find R total. R total is nothing else, just voltage source over I total, where voltage source is equal 75 volts over I total 15 milliamps. So I have 75 volts over 15 milliamps is equal 5 kiloohms. Okay, this is my R total. So we have R total. Next, we can find voltage across resistor R3. And please keep in mind that these two resistors are in parallel, so if you are going to find voltage across resistor R3, the same voltage is going to appear across resistor R2. So we can write that V3 is equal resistor R3 times I3, where R3 is equal 4.1 kiloohms times I3 12 milliamps. So V3 is equal 49.2 volts. Okay, and as I said, because these two resistors are in parallel, the voltages across both of them are going to be the same. That's why I'm going to write V3 is also equal to V2, and this is equal 49.2 volts. Okay, so we found V2 and we found V3. Let me redraw this circuit. Okay, and I'm going to have resistor R1 and I'm going to have combination of these two resistors. I'm going to call them R2, 3. Okay, so as you can see, we got the series circuit. Okay, I know the voltage across this resistor, and we found this voltage is 49.2 volts. We have also voltage source. Okay, let me write this down. I have 75 volts voltage source, and I have V23 equals 49.2 volts. So if you are going to use KVL, you can find voltage across resistor R1. So let me remind you the formula. Voltage source is equal V1 plus V23. I'm looking for V1 this time, so I have to solve this formula for V1. Okay, so I'm going to have V1 equals voltage source minus V23. Voltage source is equal 75 volts minus 49.2 volts. This is equal 25.8 volts. So this is my voltage across resistor R1. Okay, so this is my V1. Next I can find the resistance R1. Resistance R1 I'm going to find from Ohm's law by simply dividing V1 over I1, where V1 is equal 25.8 volts over I1, which is equal 15 milliamps. So R1 is equal 1.72 kiloohms. Okay, so this is my R1. Next, I can find resistance R2. R2 is equal V2 over I2. We said that voltage V2 is equal to the voltage V3 because these two resistors are in parallel. So I'm going to write that this is equal 49.2 volts over I2. I2 is equal 3 milliamps is given. So R2 is equal 16.4 kiloohms. Okay, I didn't add the powers, but of course we have to find all powers. So if you want to find power at resistor 1, you're supposed to simply write the formula I1 squared times the resistor R1. So I1 is equal 15 milliamps raised to the second power times R1, which is equal 1.72 kiloohms. This is equal 387 milliwatts. Okay. Next, we're supposed to find P2. P2 is equal I2 raised to the second power times R2, which is equal, I2 is given 3 milliamps raised to the second power times R2. R2 is equal 16.4 kiloohms. This is equal 147.6 milliwatts. Okay, and I can find also P3. P3 is equal I3 raised to the second power times R3. I3 is equal 12 milliamps is given raised to the second power times R3, which is equal 4.1 kiloohms. This is equal 590.4 milliwatts. Next we can find P total. P total is equal I total times voltage source, where I total is equal 15 milliamps times voltage source, which is equal 75 volts, and everything is equal 1.12 watts. Okay, this is one way to get the total power, and if you want to find the power in different way, and at the same moment we are going to prove our answers, we're supposed to simply add all these three powers together, and we're supposed to obtain number equal or close to 1.12 watts. So let me write the formula first. So I have P1 plus P2 plus P3. So this is equal. this is equal 387 milliwatts plus 147.6 milliwatts plus 590.4 milliwatts. So P total is equal 1.12 watts. So this is the proof that we solve the problem and all our answers are correct.